We look at the pillars of face creation and see peaceful majesty. We see a quiet cosmic nursery floating in the dark. But that image is an optical illusion. You are not looking at a peaceful cloud of gas. You are looking at a violent, highly irradiated war zone where newborn stars are physically tearing their own birthplaces apart. It takes light 6,500 years to travel from the Eagle Nebula to our telescopes. That means we are looking at a ghost. The intense radiation from massive surrounding stars has likely already blasted these columns into nothingness. We are using billion-dollar engineering to take high-definition photos of a majestic structure that probably no longer exists. In 1995, the Hubble Space Telescope took the most famous photograph in the history of astronomy. It showed 3 towering columns of cold gas. But Hubble was limited by human biology. It primarily saw the universe in visible light, which meant the thick dust of the pillars acted like a brick wall. We could only see the outside. Nearly 30 years later, we launched the James Webb Space Telescope. We stopped looking at visible light and started looking at heat. We built an infrared machine capable of X-raying the cosmos. Welcome to InnoVision Tech. Let us dissect the engineering that exposed the pillars of creation. Here is what matters about the physical structure of the pillars. They are located inside the Eagle Nebula, and their scale breaks the human mind. The tallest pillar on the left is roughly 4 light-years long. That means if you started at the bottom and traveled at the absolute speed limit of the universe, 186,000 miles per second, it would still take you 4 entire years just to reach the top. They're made almost entirely of cold molecular hydrogen and cosmic dust. In the vacuum of space, gravity is a relentless engine. Over millions of years, this gas slowly clumps together. As the clumps get denser, their gravitational pull increases, dragging in more gas until the pressure in the center becomes so intense that nuclear fusion ignites. That is how a star is born. But the dust that creates them also hides them. To see the stars forming inside, engineers had to bypass the dust. This is where the near-infrared camera, or NIRCam, on the James Webb Telescope changes everything. Visible light has short wavelengths. When short wavelengths hit a microscopic particle of cosmic dust, they bounce off. That's why the Hubble image looks like a solid, opaque rock. Infrared light has much longer wavelengths. It doesn't bounce off the dust, it slips right past it. The James Webb Telescope acts like a cosmic X-ray machine. By capturing these long infrared waves, the opaque dust cloud suddenly becomes semi-transparent. To achieve this, the engineering is brutal. Infrared light is essentially heat. If the telescope itself is warm, its own heat will blind its sensors. The mirrors and instruments of JWST must be kept at -390 degrees Fahrenheit, permanently shielded from the sun by a tennis court-sized sun shield. That extreme thermal engineering is the only reason we can peer inside the columns. You're watching InnoVision Tech, where we analyze the systems that shape our future. If you want to understand the reality of cutting-edge optical engineering without the fluff, hit that subscribe button. When James Webb looked through the dust, it didn't just find baby stars, it found a massacre. The pillars of creation are actively being destroyed by a process called photoevaporation. Just outside the frame of the famous photograph, there is a cluster of massive young O-type stars. These stars are incredibly hot and incredibly bright. They're blasting the pillars with a relentless hurricane of ultraviolet radiation. This UV radiation acts like a cosmic sandblaster. It hits the cold hydrogen gas, rapidly heats it up, and physically boils it away into the vacuum of space. The only reason the pillars still exist at all is because dense knots of gas at the very top of the columns are acting like umbrellas, shielding the gas directly beneath them from the radiation storm. But the storm is winning. The newly forming stars inside the pillars are in a race against time. They must gather enough mass to ignite nuclear fusion before the ultraviolet hurricane completely strips their birth cloud away. Finally, we have to talk about the speed of light constraint. The Eagle Nebula is 6,500 light-years away. When James Webb captures an image, it's not seeing the pillars as they are today. It's capturing light that left the nebula at the exact same time human beings invented the wheel. Astrophysicists analyzing data from the Spitzer telescope previously noticed a rapidly expanding cloud of scorching hot dust directly next to the pillars. This is the exact signature of a supernova, a massive star that exploded at the end of its life. The shock wave from that explosion was already barreling towards the pillars. Based on the speed of the shock wave and the distance, that supernova likely slammed into the pillars roughly 6,000 years ago, physically obliterating them. But because light takes so long to reach our optical sensors, we won't see the destruction happen in our skies for another 1,000 years. We are studying a beautifully engineered photograph of a ghost. The James Webb Space Telescope proves that our eyes only tell us a fraction of the truth. By engineering sensors that can capture the invisible infrared spectrum, we uncovered the brutal mechanics of star formation. The pillars of creation are not a permanent monument in the sky. They are a temporary, violent clash between gravity and radiation, and they are already gone. If this breakdown of deep space engineering changed your perspective, hit that like button. Subscribe to InnoVision Tech for more clear engineering analysis.